Hi, my name is Judy McKay. I'm an account director for Planet Software Testing. This presentation is about quality, particularly about quality being key in successful projects. And many people talk about quality and the importance of quality and the importance of building quality in, but in reality, it isn't done very often. So this presentation talks about 8 steps that you can use to help guide successful projects. So the first point here, don't force the project into a life cycle that isn't suitable. If it doesn't make sense for the project to follow for example, a fully defined requirement cycle, then don't force it into a waterfall. But conversely, if you have regulatory requirements and you have to have full sign-off on requirements before you start coding, don't force it into Agile. Be realistic about the right kind of life cycle model. So remember, when you're pick the appropriate model depending on the project, the team, the schedule, the realistic schedule, the budget that you have, and the documentation requirements that you may have. Now remember, documentation goes 2 ways. It's the documentation that you get, like requirements and things like that, as well as documentation you have to supply, which could be things that are required for regulatory approvals, like documented test cases, documented static testing, those kinds of things. So be realistic there. Think about the whole gamut of the things that you have to look at. This one seems obvious, but it's amazing the number of projects that I've seen and that we've seen where vendors are not held accountable. And it's an interesting thing to think about because there's a contract. There's money involved there. But often there is not enough well-defined entry criteria to actually hold a vendor to it. So, and it's just a fact, development vendors are going to make more money if they charge time and materials for support if they've made a low quality product. Okay, that's very negative. It's a very negative feeling, but it's true. So sadly, your motivation there, if they're getting time and materials for support, is not really to produce the best product, is it? That kind of would be dumb. So think about your motivators. Think about the motivators that you're setting out in your contracts, in what you enforce, because you're going to get what you actually are pushing for there. Let's talk a bit about cost of quality and considering that in everything that you do. So generally, the rule of thumb here is that every defect costs something. It's cheaper if it's found in the phase in which it's introduced. Okay, that makes sense, right? So if you have a requirements bug, but you don't find it until user acceptance testing, ooh, that's going to be expensive because it should have cost you $1 if you'd caught it in a requirements review. But instead, you caught it in user acceptance testing. So now that bug is now $499 more expensive than it should be. And that's called an escape. So what we want to make sure is that we don't have escapes from the various phases of the project. If we have a requirements problem, it should be caught in requirements reviews. If we have a coding problem, it should be caught in unit testing. If we have a design issue that's causing integration problems, it should be caught in integration testing. If it's something that perhaps could only be caught in end-to-end, something that's introduced because we've got systems integrating with each other, data, something like that we couldn't have caught earlier, then that's a $100 defect. You can see the cost rises as we get further down the chain. As more people get involved, it takes longer to fix it. You have to go back and redo all of the testing that's happened beforehand. Don't jump to code. Seems like a good idea. Really not a good idea. I understand it looks good on a Gantt chart, but PMs really like to be able to say, look, we've started coding, because everybody understands, ooh, progress is being made. Ooh, this is good. But if you jump to code before you're ready, before the requirements are understood, before the users have bought in that this is what they really want, before the developers understand developing, it's going to cost you more in the long run. So don't jump to code because it looks good on the Gantt chart. Think it through. Start when it's appropriate to start. Make sure you know what you need and what you want. And in a lot of cases, it's part of the requirements gathering that fleshes out what you really need and what you really want. Say you're going to say, we're going to change our processes. We're going to have a whole new approach to this. Going to do some process analysis. We're going to chart these out. It's going to be great. Okay, do that. Do that first, and then figure out what to code. because you don't want to be halfway through coding and then say, oh, actually, we're going to do that completely differently. That's just going to cost you money. Suspicious, suspicious, I know, but verify vendor testing. Make sure that you've set measurable entry criteria so that you know, did you meet the entry criteria? And this ties right back with cost of quality, right? So are defects getting past them? Why? Why are they not testing for these things? Why are these things not being covered? So set things that you can basically evaluate objectively. How many defects are they? What's the criticality of the defects? That there's nothing that's broken major functionality. Those kinds of things, the things that you would expect to get, but might not. So set those measurable entry criteria. It will save you an awful lot of disagreement, shall we say, later. Validate that those criteria are met. Now, I know that seems obvious, right? Why would you set them if you don't validate them? Happens all the time. People have the best of intentions. They set these up, and then they never check them. So make sure that you have a way to check them. Often this is, again, by writing some kind of a smoke test or having a set of tests that are run as soon as you receive a release. And then validate that those criteria have actually been met. And this is where shortcuts really aren't going to help you in the long run. SMEs, or subject matter experts, are not primarily testers. They're primarily users. So if they're doing testing, they're testing from a user's standpoint. Users hope things work, quite frankly. They try to go the positive path. They try not to break stuff. They try to just behave themselves. They're not testers. Testers go in saying, oh, I can break this. And trying to make sure that A, it works as it should, but that it also handles error conditions correctly. So that's not what a SME does. A SME is there to see if it will work for what they do, but not for all of the corner cases and the things that it might do just once a month or once a year, or, ooh, but you know, it's kind of on the border, this person does and this person does, right? They're not primarily testers. They don't think like testers. So if you're going to do testing, make sure it's done by testers. So I touched on this with the last slide, but we want to make sure that we conduct an effective user acceptance test. And that means we're using the right people to do the right kind of testing. Okay? Testing should align with the future processes, not with what you do today, but what you plan to do with this new system. If you're rolling out a new ERP system, for example, you probably want to change the processes and have some new and improved ways of doing things, maybe some different areas of authority, different approaches, just different processes in general. So you want to make sure that the testing is going to align with those future processes. There's no point in testing it for what you're doing today, because that's not the plan for what you're going to do tomorrow. Make sure you allow time for defect fixes and process changes. Okay, so one of the problems with the user acceptance test is we're using our users who have their day jobs, and they're not going to be so happy about having to come back and retest fixes. So you want to build that in, or use testers to validate the defect fixes. But, you know, somehow you've got to judge that user time so that you use it as effectively as possible. Now, process changes is another one, because even with the best BAs, sometimes you end up with future processes designed, and then you kind of use them against the software and you go, ooh, actually, that's not going to work that well. So sometimes you do need to change processes, and you might need to retest with those new processes or the updated ones. So, you know, making time for that makes the user acceptance test schedule a little more difficult, but it's reality, you know, and this is what happens on most projects. So building the time in for that will really save you a lot of heartache when you've got unhappy users that have to get back to their job and were only allocated 3 days from their manager to work on this. It's really important to reward quality, not schedule. Now, I know it's more fun to have a big party when the end date comes and everybody says, woo, 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 we delivered on time, yay, yay, yay. Balloons, cake, life is great. But is that really what you want to reward on? So it's a known fact. Higher quality software gets to market faster and has much lower maintenance costs over its lifetime. So the obvious derivative of that is, if you want to get it out sooner, make it better from the start. Build a better product. Plan a better product. Build quality in. That's the only way you're going to get your product out there faster. So all back to that quality being so key, and rewarding the quality, not the schedule. Making sure that we actually are thinking about it and building that highest quality software that we can. And in the end, it actually ends up cheaper on a shorter schedule.